Good afternoon, good morning. Thank you for taking time out of your day to join us. This is a session which we're looking at basically the state of Apache Iceberg, and more in general, we're looking at the lakehouse. We have quite an interesting panel of guests here. I will have to apologize to you in advance. We are having some technical difficulties today, or at least we are not able to see each other. So the conversation will probably be probably a little more disjoint than we would like it to be, but we've got pretty good diversity of opinions here, and I think you'll still find the discussion pretty compelling. So why are we having this discussion? I think that's going to be a question I'm going to throw out to the panel, but I'm going to take up a few opening thoughts here, which is some say the lakehouse, the data lakehouse, which is a term I think we'll probably debate here, is about the open choice, about an open table format. My take on this, though, and I've recently concluded some fairly in-depth research here on the market landscape, is that really what the real driver here has been the need really for to get better confidence in the data that we have in our data lakes, and that really starts with ACID. And we're not here talking about turning this into a transaction database, but the idea being that is the data that we are using from the data lake, is it current? Is it consistent? Is it not corrupted? And until now, if you wanted to have that level of assurance, you needed to write that into the application, which was not necessarily the type of thing that data scientists or data engineers want to do. They don't want to be running their own transaction engines. So anyway, and by the way, that same concern was ultimately an animated discussion about data mesh, which if you were on Subsurface earlier today, Jean-Marc basically opened the day and talked about the basic topic that actually, from what I've seen from my experience on LinkedIn, has been pretty much the hottest topic, in data management over this past year. But the thing is, I've also been seeing rising interest, in data lakehouse. And I think, so one of the questions that I think really need to answer is, why are we having this discussion now? Well, my take on this is that over the past year, we've really started to see commercial ecosystems really starting to solidify around this. Now, we're still fairly early on with regard to market awareness. I've spoken with lots of practitioners, and there's a lot of lack of clarity as to what lakehouses are, or whether that's really the appropriate term. We'll talk about that. So demand's still pretty latent, but definitely where there's smoke, there's fire. What we are going to do in this session is we're not going to be doing a competitive, bake-off or smackdown between the different open source, data lake, table formats. We are going to focus specifically on Iceberg. This is not necessarily meant to be an endorsement of Iceberg. But we do have the creator or the co-creator of Iceberg here. So I think you will be getting some endorsement from some quarters here. So without further ado, I'd like to introduce our panel. And we're going to go one by one here. As I said, unfortunately, our video here is not working. We cannot see each other. You can hopefully see us. So what I first would like to start is with Russell Spitzer. He is software engineer for Apple Cloud Service. Russell, can you introduce yourself and give us a little bit about your background? And we promise not to ask you anything about the next model of iPhone.
All right. Well, so yeah, like I said, I'm Russell Spitzer. I kind of got into the big data world starting at DataStax, which was a Cassandra company. I spent a lot of time with Spark and Cassandra and integrations between that. And then I joined Apple, where now I pretty much exclusively work on the integration of Apache Iceberg and a lot of other technologies. So moving from one open source technology to another with slightly lower latency. Or higher.
Okay, thanks, Russell. Next on our panel is a person we can blame for this whole mess or compliment for his own mess, and actually is having a real red letter day. And so I'd like to introduce Ryan Blue. You are a co-creator of Apache Iceberg and the CEO and co-founder of Tabular. And evidently, you're having quite a red letter day today. So tell us a little bit about your background. I will later ask you about how you came to develop Iceberg. But right now, I'd like to know a little bit more about your background and tell us a little bit about what's happening with your company today. It's a red letter day for you.
Thank you. Well, so I guess I've been in the data space for a long time now, way back to my government days. Then I moved to Cloudera and Netflix, where we started Apache Iceberg. After doing the Iceberg rollout and production deployment at Netflix, we thought other people could really use a lot of help with this, so we created Tabular. And Tabular, as of yesterday, actually is open to the public, and you can go sign up at tabular.io. So we're really excited to have our launch happening and to be this far along.
Congratulations! I'm sure the paparazzi are now lining up at your door as we speak. And last but definitely not least, and this is really what I want to talk about, the ecosystem that's forming around Iceberg, is Robert Stupp. He's open source engineer at Dremio, a company you may have heard of, and also the tech lead for Nessie. And Robert, I will ask you shortly more about Nessie, but right now, just tell us more about your background.
Yeah. So currently I'm working, as I said, for Dremio. It's basically really all the things about open source Nessie, and which is at the core of Dremio Arctic, of course. So my role is mostly about being a tech lead and of course committing a lot of code, but it's a lot about the user/developer experience, the various query engines, integrations, how Nessie and especially Apache Iceberg play together. And of course, thinking or planning or implementing the next things which are on our roadmap.
Creating Iceberg. Give us, kind of the background and, what really drove this and what was basically your intent and your design goals, for doing this.
Thank you. Really quickly, I think we may have skipped Jordan. You cut out there for a second.
I'm sorry about that. Gosh, how did I do
Thanks,
that?
Ryan.
Yeah, Jordan, my apologies to you. Jordan, this is what happens when you don't have video here. We have Jordan Chigani, who's basically the founder and CEO of MotherDuck, which I'm sure you are for wetlands preservation, but I have a feeling that's not what you do. I think this has a lot more to do with DuckDB. So can you tell us a little bit more about your background?
Sure. I was one of the engineers that helped create Google BigQuery. I worked on that for a long time. I worked on the storage side of things for a while. And so very interested in and excited about sort of the things that are now in Iceberg and Tabular. There was a bit of a war between sort of like should the data warehouse or the data lake kind of reign supreme, and it seems like we're working on some architectures that sort of give you the best of both worlds. I'm now the founder and CEO of a company called MotherDuck, which is doing serverless analytics based on DuckDB.
Okay, sounds good. And my apologies, Jordan, for that. You and I've actually we've actually crossed paths quite a bit, during your previous lives, over at Google there. Okay, getting back to basically our regularly scheduled program. Ron, give us a little background on the origins of Iceberg, Apache Iceberg. What drove this? What was your approach? And give us a little more color and background about what we're talking about here.
Yeah, absolutely. We created Iceberg to address the three main challenges that we had at Netflix at the time. Usability was very, very poor because you couldn't count on your tables having a certain behavior, either when writing to those tables or when trying to maintain them over time, evolving schemas or things like that. We also had, constant performance challenges with the structure of the old tables. And we felt that very keenly because we were on S3 rather than HDFS, and everything took 10 times as long in the cloud, which is why I think we got to this, on the early side. And then just, general correctness issues. The old formats and some of the new formats just have correctness issues, so they are just not as reliable. And people really don't like having operations that only kind of complete or only kind of give certain guarantees. So we really wanted to fix all those problems, but also a goal from the start was to do this in a way that other people could adopt and build on and really invest in. And that's what excites me the most about being here at this conference, is that there are so many different people talking about Iceberg, so many different vendors supporting it these days. I really think that we're finally delivering on that goal of being a project that the broad community feels like they can invest in. And it's technically there and on the community side as well, welcoming and open to anyone who wants to contribute.
Yeah, I think that's what makes this, it's made this area very interesting to me, and why I dove into the research over the past, I guess about 6 months or so, which is that there really has been a sharp pickup, in activity, and it is, and in many cases it has been, very broad based. I would like to actually kind of to seg to Russell, as you actually are using Apache Iceberg, and basically, Ryan basically spoke about some of the key criterion that he was trying to, or basically the requirements that he was trying to deal with: usability, the fact that table performance was behavior, I should say, was pretty flaky, and not always being sure of having the right data. I want to ask you, which is basically, why did you decide to use Iceberg, and what are basically what were the goals that you were looking for, the benefits that you were looking for?
Yeah, so obviously I can't go into too many specifics on this, but as a general user coming to someone looking at Iceberg, it solves a lot of problems that you just can't figure out when you have file-based tables without having a lot of ancillary machinery around it. So being able to have full ACID basic transactions is really important, especially if you want to start handling cases where you want to atomically change data that's already in your table. So, when we see use cases for things like GDPR and stuff like this, where you want to maybe only change 10 rows in a single file, you need to be able to atomically swap out that file. You can't rely on guarantees that the file system is always going to correctly do something, or that the network is okay, or that any particular transaction goes through. So it's really captured a lot of interest for users, I think, because of that. It really just makes a whole new set of things possible at a scale of data that used to not be possible to really do.
Yeah, I mean, put it this way: would you consider this to be the best of both worlds between data lake and data warehouse?
I mean, those terms mean a lot of things to a lot of different people, but I really think it's getting much closer to the idea that you can scale up the SQL that developers are already familiar with onto a system that will scale pretty much independently, is based on open software, and can completely separate compute and storage, which I think are all real key factors in why it's so attractive.
Right. So, Jordan, I want to turn to you, because basically you're taking your approach from a very different perspective, and I think, and so basically, what does the lakehouse mean to you? And in terms of where do you see value? Do you not see value? So give us a sense of where you're coming from.
Sure. I think one thing that I think is disappointing about sort of the proliferation of data lakes has been sort of the standardization on file access. That basically, if we're kind of sharing data, and what we have to share between each other is really a file, that gives so little flexibility and freedom for the actual implementer of the query engine and of the storage system as well to be able to innovate and to give you high performance. And I think what I think I like about the lakehouse is that it starts to sort of raise the level of abstraction above the level of a file to really a table interface. And so I think that the real kind of where the world needs to be is you standardize on a table, which is which you interact with it with SQL, and rather than interacting directly with files. And obviously, kind of if you're have multiple different systems interacting on something like a data lake, you're eventually going to have access to the physical files. But I think at some point that becomes a lot less important as sort of what the actual format of the file is. And when you can give these sort of higher level primitives, you can give ACID transactions, you can give the ability to coalesce and compact data in the background, repartition data, like so that you can get good performance. Sort of as soon as you raise that level of abstraction, you open up the door to a lot more innovation, both on the storage side and on the query side. And that's, to me, that's actually what I like about systems like Iceberg.
Do you see any drawbacks?
On the other hand, if you still have to give people access to files, and I think Parquet, for example, is there have been sort of this Parquet version 2, which is which would be awesome if we could move to that, but part of there's problems where everybody still is interacting with files, means that it's hard to innovate on the format side of things, and there's some security level things that are harder to do. Dynamic data masking, column level encryption, some of those types of things. I think that we'll eventually get there. I think also making sure that metadata is actually one of the really important things in a data system, and making sure that you can have rapid metadata updates are going to be also important, to be able to do things like real-time updates. My guess is that these are problems that are going to be solved, but I think they are some of the drawbacks with some of the current tech.
Right, and this is where I'd like to bring in Robert, because basically, one I think the interesting phenomena what we're seeing with the, at least with the open source lake houses, is that we're starting to see kind of an ecosystem starting to evolve, and in some cases, basically sub projects, if you want to call it that. And you've been involved with Nessie, and basically Jordan was talking about the importance of metadata. So can you tell us basically where something like Nessie would fit in?
Yeah, of course. So first of all, I mean, Nessie was built around supporting basically a lot of table formats, but in the end, the Apache Iceberg community was the community that was very open and welcoming the contributions of Nessie. So, and that's how Apache Iceberg basically became the table format in Nessie.
Mm-hmm.
With respect to what makes it lakehouse / Nessie or very important or very special, I think it's a lot of combinations. For example, things that people would maybe naively or kind of expect or desperately need, like multi-table transactions. I mean, you can manipulate a ton of tables in a single transaction. So what people are used to from relational databases, right? Do it begin transactions, update these many tables, do a commit, or just throw it away with a rollback. Data lakes didn't have that. So it's like having your salary on your bank account, but your bank account balance isn't updated, so you can't even buy a single drink. I mean, what's the point of that?
Well,
so yeah,
I prefer to have a transaction system on my bank account that only records deposits and no withdrawals. But that's a
yeah. And I think there are other maybe nasty but necessary requirements, like all these regulatory or legal requirements to know, okay, how did your whole data lake look like at that certain point in time as a consistent view to all the tables, which is comparable for people familiar with Git. It's like a tag. Like you put a stamp on your whole data lake, and Nessie makes it possible to query exactly the state of the whole data lake at that point in time.
Well, let's kind of get a little specific here, because in terms of and this sort of points to the need for sort of ancillary projects, which is that Iceberg, as I understand, and Ryan, I'll have you jump back in here for a second. Iceberg collects a fair amount of metadata. I mean, can't you do? And Robert, I'll come back to you on this, but with Iceberg, can't you with the way that you collect metadata there? Can't you do time travel can't you do time travel today on Iceberg with just plain Iceberg without any other projects?
So yeah, that's entirely correct. You can time travel. You can also tag older versions at a table level rather than at the warehouse level. You can also branch and do, essentially like stack up some writes and then fast forward your main after you've audited that the data is correct, and newer use cases like that. There, I think, is an open question here between, is it better to do that at the metadata level where you're capturing the state of the entire warehouse, or at individual table level? But I think we all agree that we definitely need those multi-table transactions, and this area, like Jordan said, metadata is incredibly important, and getting to the point where we can do more of these operations is definitely an area of tremendous effort and work right now.
Now, for what Ryan was talking about, Robert, I'll come back to you. Where would Nessie pick up and Iceberg leave off?
Yeah. So as mentioned, I mean, like this multi-table transaction kind of thing, but also thinking about data experiments so answering questions like, how would my data lake or my production data look like if I use a different schema on my tables? Right? If it doesn't work, throw it away. If it works, maybe merge it back to your production main branch kind of thing.
Mm-hmm.
But I think what also comes into play is it's a bit far bit ahead of time, but maybe not so actually. But CI/CD for data, I think that's a really important topic. I mean, having kind of automated data validations with automated publishing of that data.
Mm-hmm.
You don't want to go to your boss and say, and he let him figure out your data is inconsistent. That's maybe not the best idea to have.
Mm-hmm. Interesting. Anyway, I kind of want to get this is sort of and we had a fairly animated discussion about this last night when we were just kind of just hooking up and syncing. And so I want to bring this up right now, which is that, is lakehouse really the operable term here, or is this just marketing buzz? We'll start with you, Ryan, and then we'll go through each of you folks and get what you think.
So I think that's a good question. I've found that the main problem is that we don't agree on a common definition of what it means. People see different things in the term. And so I always like to clarify, like, what do you mean by lakehouse, right? Earlier we were talking about the good parts of a data lake and the good parts of a data warehouse. And I think that, joining those two things together is a perfectly valid definition of lakehouse that I like, because I think that, the goal of Iceberg is to do exactly that, right? It's to give you the SQL behavior and guarantees of the data warehouse world with the flexibility of using, any engine and decoupling your storage from compute of the data lake world. On the other hand, I think it's often broadly applied. Like, we're a lakehouse, we build a lakehouse, Iceberg is a lakehouse, this other thing is a lakehouse. And I don't know that any one of those definitions is actually correct, right? Like, Iceberg is a data format for very structured data. And most people say a lakehouse architecture, I guess now we're saying lakehouse architecture, so it's a different term still, but that includes unstructured data. So, it's very nebulous to me, and I like to just be specific.
Well, put it this way. Okay. Well, I'm going to ask each of the others, but it's sort of making me wonder, which is that is a data lakehouse in terms of how it's being currently, envisioned, really the revenge of the SQL nerd. I mean, yes, we could do Python routines on it that it's in there, but the way the whole table structure is premised, that we premise this on a relational table structure. So I'm going to ask each of you. I'll start with Jordan. I'll start with you, which is, do you see this as being the revenge of the SQL nerd, or is this something which basically is available to all comers?
So there's a great paper written by Michael Stonebreaker and Joseph Hellerstein called "What Goes Around Comes Around."
Mm-hmm.
And it basically talks about there's like these kind of endless circles in the database world about like a number of things, and one of those is schema on read versus schema on write.
Mm-hmm.
The lake house was the data lake was premised on schema on read, which is you basically write whatever garbage you want. And you can sort of see where I come in on this. But then when you read it, you can apply whatever schema you want to it. And it turns out that if you want to actually have reliable understanding of your data, you kind of want to make sure that only the right things get in. So you want sort of schema on read. But just sort of almost like dynamic versus static typing in programming languages, there's this sort of these sort of wars that once you go too far on the one side, things tend to switch back on the other side. And so I really see kind of the lakehouse as a movement towards schema on write versus schema on read. And you can do SQL over either one of them, and the SQL probably is a little bit more natural on the SQL on read or SQL on write side.
Mm-hmm. Right. Russell, as basically you've dove into the lakehouse. What's your take on that?
Yeah, I mean, I like hearing from everybody else. I mean, basically, when I hear lakehouse, I'm usually thinking about the users I'm interacting with directly, who are seeing something and want to know something specific about their data, and really what they just want is they want to be able to do the same things they could do on their relational databases on a data size that is enormous, or basically they can't fit their data in Postgres, and now they want something that behaves pretty much the same. So they need a set of technologies that lets them do that. Mm-hmm. And I'm definitely agree that the schema on write is kind of critical to actually make this work at scale. Like, it's very, very difficult to write the kind of optimizations you need to really make querying big data possible without knowing a lot ahead of time. Like, I think the key to the big data and the data lakehouse is the ability to not read all of your data all the time. And the only way you can do that is with metadata layers and things like that, so you can avoid reading in the first place. So I think that's kind of the killer feature kind of coming through all of this. And right. Whether or not anything is or isn't a data lakehouse is hard for me, because it's more just like I'm talking to a user and I say, well, these are the technologies together that will satisfy your goals. Mm-hmm. And that's kind of where I am on it.
Yeah, it's interesting. It's really been a pendulum swing. I mean, and I'm sometimes convinced, and and it's not just in data, but that you see the history of IT. Sometimes I think nothing that's new has happened. We just reinvent each time with some new knowledge and some new wisdom. And so when big data came in, it was like, schema on read. Don't let's just get the data in there, and as soon as you transform it, you've already basically reduced it. You've lost some fidelity. Versus basically what we're talking about here is the repeatability. So, Robert, I'd like to finish up with you on this question, which is that, what's your take on this?
I pretty much agree with everything that my four speakers said. I mean, like adding the databasey things, assuming that we are talking about structured data, basically, like things that you can put in tables and columns and maybe add indexes or materialized views on that. So yeah, like adding these databasey things to a data lake, if that's an explanation for a data lakehouse, at least in my opinion, maybe. Mm-hmm. But I would also like to add that, I mean, we're talking about new things and new fancy things and such, but also having the ability to remove all the burden of like manually or heavily scripted file system maintenance stuff. If there's stuff that can take these maybe boring, repetitive, and potentially error-prone things away from users, so that they're free to do things that they want to do, I think that's something a lakehouse could really do, and could really where people could really benefit from.
Okay, I have. We'll see how much time we have here. I have one question I'm burning to ask. I'm going to spring on everybody here, and it's going to be a complete surprise. But we like to live dangerously, which is, do you see if we accept that we use the term data lakehouse for the moment? Do you see it? Will it replace the data lake, or will it replace the data warehouse, or will there still continue to be a reason for each of them? I'm just going to go in order of how I see your the gallery here. Russell, we'll start with you on that.
Yeah. The big trend, I think, in almost all of this is kind of this layer disappearing from end user knowledge. Like, it just eventually gets to a point where they don't know what's going on. So regardless of what terminology we have, I feel like that's something that folks like us on this panel will be talking about a lot. But what we end up presenting to end users is going to be much simpler. Like, they are not going to be knowing the details of how this is all working under the hood. And I mean, ideally, I think that's why there's so many companies out here which are trying to do this kind of data lakehouse as a service, warehouse as a service, because managing all this and knowing those finer technical details is I think pretty niche. It's going to be kind of similar, I think, probably in the future to how many people use SQL with like a relational database versus how many actually understand how the internal query optimizers and file layouts actually work, like in Postgres versus MySQL DB, or all that kind of stuff. So I kind of see it kind of vanishing away from public perception, but our debates will probably still be very vigorous, and we'll be yelling about this for a long time.
Ryan, your turn. Will lakehouses replace or supplement data lakes and or data warehouses?
First of all, I want to steal Russell's answer, because he's absolutely right. And that was one of the reasons why we created Iceberg, was to make these responsibility, the file management responsibilities that Jordan was talking about, disappear. We should be able to automate all that stuff just like a real grown-up database. And so, that's definitely the trajectory of the data lake world.
We'll replace the data lake, and we'll replace the data warehouse.
Well, I think it is replacing the data lake. So you will still need some things, like the idea of dumping a whole bunch of unstructured data in S3 isn't going to go away, right? What we will see is we're going to stop losing structure, right? We're going to share tables with one another instead of files. And, we're generally going to be better about holding on to the structure that we have, but you still have video files and you still have unstructured things that you need to keep as a source of record or source of truth. So definitely on the data lake side, we're growing more towards data warehouse capabilities. I think data warehouses are doing the same. And you can see like BigQuery and Snowflake saying, hey, there's a lot of data out there that is just stored in files in S3 that people aren't loading into our database for whatever reason, and we want access to that. And that starts making everything look very, very similar, where the data warehouses become query engines on top of Iceberg tables. And we get this sort of merging of the two worlds, which is where I think everything is going. We're going to merge the two worlds together and, bring a lot of that database knowledge into what we're doing, what we've been doing in the data lake world. And then hopefully, like Russell said, users won't have to think about any of it.
So, Robert, do you see the worlds merging or diverging or replacing each other?
That's a tough question for me, to be honest. I think it's always an evolution kind of thing. It's easier to say we just replaced our data lake with the data lakehouse, but there's so many things that just sit around all these things, all these processes and stuff. So I'm actually, I think it won't go completely away. And as Ryan said, there's a ton of unstructured data, videos, and stuff like this. So there's maybe also some chances to get metadata out of these things and put these things in a lake house and add some value to that unstructured data.
Okay, and Jordan.
So I think this question, first of all, it's good to hear that there are no lakehouse maximalists here. I think some people, just like there's Bitcoin maximalists that are like, Bitcoin's going to replace fiat currency. Sometimes you hear kind of lakehouse maximalists, so like like everything else is going away and everything will be the lakehouse. Because I think that I don't see data warehouses are not going to move to lakehouses for their primary storage. There's too many advantages to performance and security and manageability of kind of owning your own data. I do think that you're already seeing them already embracing, as Ryan was saying, being able to read data that that people have chosen not to include in the data warehouse. I kind of see data lakes as people are using them. I can see them going away actually. There's a bunch of like video files, etc. that you kind of need to store somewhere, but I think that the lake house was the data lake was sort of like a path dependent organism that it showed up because people were using Hadoop, and like they had a bunch of they needed to throw their data somewhere, and so they threw their data here. Turned out to be a big mess. The most high-powered room that I've ever been in was like Google had this customer advisory board that had CTOs of like Fortune 50 companies in there, and like we asked them about their data lakes, and they were pounding the table, angry that they had invested so much in this and they hated them and they couldn't figure out what to do. And the lake house gives them something to do. It's like, oh my God, this thing is broken and it's breaking our company and we're spending all this money and it's insecure and it's just this mess. The lake house is something like that gives them an out. And so I see people really kind of jumping at the lakehouse technologies because they give you a lot more control and understanding of what you actually have. And then I see kind of the more traditional uses of a data lake kind of going away a little bit as more people start to build on top of the lakehouse.
Okay. Final question, and I'm going to give this to Ryan, which is, what's on the roadmap for Iceberg?
Well, in an open source project.
Or can we close the patent office now and Ryan, you can go up into retirement?
The answer is
I would love to retire.
Pull requests are welcome. So that's the future.
Yeah, exactly. That's what I was going to say. That it really is driven by the amazing community. I can tell you what we're driving for. So in the next year, Tabular, we're looking to support and work with Apple on encryption. So I think encryption is going to be a really great feature to have in the format. The Python implementation and possibly getting closer to C++ and native implementations. Love to see that improving. That is bringing so many new people and use cases into the community. Multi-table transactions. That is just being able to release data at the exact same time, even if you've staged it and it's not a real transaction. Like those sorts of operations we get questions about all the time. And we want to deliver true multi-table transactions along with that. Further improvements to the metadata layer and some of those things, better indexing, we've got some proposals for, and better statistics, and basically a lot of things. It's an ever-changing community with a lot of talented people putting in an amazing amount of effort.
And I'll ask you, as basically someone's been involved in creating this, are we ever going to get to the point where we basically have the same? We have basically we've leveled the playing field in terms of performance, in terms of control, in terms of governability, as with data warehouses. Do you see that happening?
So in a format, those things are extremely hard because a data warehouse has so many runtime components, right? Now, I think that we're pulling apart the data warehouse model and moving to separate compute and storage, and Iceberg helps us along that path. But there's a ton of metadata management and caching and other tasks that need to be done and like sort of warmed up in order to have the kind of experience that you have with the data warehouse. And so I don't see that going away or being replaced by a format like Iceberg anytime soon.
Gotcha. Anyway, Ryan, and everybody here, Ryan Blue, Russell Spitzer, Robert Stupp, and Jordan Degani, very much appreciate your taking the time to share your insights on Iceberg and the data lakehouse, if we've at least temporarily agreed to call it that. Anyway, this is Tony Bear, and I'd like to thank the folks at Dremio for hosting this conversation here at Subsurface. Thank you.
Thanks, everybody.